So I adapt these notes from the textbook and just take what I like and change what I don't. And it's an open source textbook, so as long as I attribute them, that's perfectly fine. And I don't know if this is that useful for one-sided limits, but it really made me laugh, so I included it. If we approach Niagara Falls from upstream, we're going to be much higher elevation and have different issues than if we approach from the downstream side, which will also have issues. Water falls fast and it's heavy and it hurts. Anyway, that's what one-sided limits are all about. Being panicked on Niagara Falls or something. I don't know. But the idea is, right, we looked at this before, right? Over here, one-sided limits make sense because the behavior from the left was different from the behavior from the right. Well, let's talk about one-sided limits. It's pretty much just exactly what you saw visually. It could also appear on tables, right? This was the limit from the left. This was the limit from the right. And it feels maybe a little backwards with these arrows because this is an arrow pointing to the left. But that means we're approaching from the right side, right? This is the point. We're coming from the right. So that's what one-sided limits are. This is how we write it. The left limit, the limit from the left, is just approaching only from the left. And it's written almost exactly the same. The difference is this minus sign. As it's an exponent. It's not an exponent, but that's where it goes. It's a superscript, if you really want to be technical. All right. And that's the only difference in notation. It's a regular limit, but if we only care about the behavior from the left of the input, then we'll write it with a minus. And if you're curious on how you can remember that, just think of the number line. If you're approaching 0 from the left, right, you're negative. If you're approaching 0 from the right, you're positive. So that's how you can remember. Also, I don't know why. For some reason, this really looks like somebody's face. I don't know how left looks like eyes, but for whatever reason, it does. I don't know. Anyway, so let's do some practice with one-sided limits. All right, so at x equals 0, that's going to be here. Let's start with that one. The limit as x approaches 0 from the left of this function. What is it? Well, as x is getting, our input is getting really close to 0 from the left, what is our output doing? Again, this is where the input equals 0. It doesn't matter the value itself. But as we get really close to an input of 0, what's our output doing? Our output's getting close to 1. Whereas the limit as x approaches 0 from the right is going to be a little different here. Right? As we approach an input of 0 from the right, our output is approaching 2. All right, and now we just do that with all the other ones. So pause the video and try to see if you can get these other ones and do the right notation as well, okay? So try to get the ones for 1, when the input gets close to 1, when the input gets close to 3, put the notation, pause the video, and then we'll see if we get the same answers afterwards. I'll talk through it. All right, the limit as x approaches 1 from the left. Well, as we're approaching an input of 1 from the left, our output. Oh, we can notice right off the bat, right? That here, approaching from the left and approaching from the right, we're approaching the same number here. We have the same values. So this is equal to an output of 1. This limit, right? This function, it has an output that's approaching 1 as we go along these arrows. And if you want to do a little shorthand, you could write it like this. This means they're both equal to 1. It's a compound equality. Perfectly fine to write. Or you could write the notation just like we did up here and just put 1 for both of them. All right, and last one, the limit as x approaches 3 from the left, and the limit as x approaches 3 from the right. What are those? Well, as our input is getting close to 3 from the left, our output is approaching -1. As our input gets close to 3 from the right, our output is approaching +1. We'll fill it in just like so. And again, what limits are all about is as the input gets close to something, what does the output get close to? And that's why I'm drawing these arrows. All right, I think it makes it a little easier to see. And that's one-sided limits. I think that's the end of the video. Let me double check. Yep, that's the end of the video. The next video is interesting because remember when we talked about this limit, this sort of limit in a previous video, I said the function value being down here doesn't actually matter. The function value could be anything. Now we get something really special if the function value equals the limit value, and that's called continuity. And that's what we talk about in the next video. So we got that in this situation right here. And technically in this situation here, in this situation here, in infinitely many situations, this function is continuous in a lot of different places. We'll talk about what continuous means in 2.2.4. Bye-bye. Toodaloo.